Okay, we're going to move on to question 9 now. Question 9 asks, with the identify tool, what's the elevation at the center of the center circle? So I did not need to zoom out. We'll go back into this guy. And we want to know what the elevation is here. Well, if you look, we're just right off the Hudson River. I think that's the Hudson. So we're going to be very close to sea level. We better be. This is a river here. We're in New York. You could add a base map if you weren't sure where this is, but this is in New York City. So let's zoom back in to this guy, and we should be expecting a very low number. I just say that because you need to have ways to evaluate basically what you're doing. So I'm going to use the information tool again to open this, but then we need to set where we're identifying from. We want to make sure we're identifying from the actual elevation model, because this is where we're going to get elevations from. And then we click here again to reset it. And the elevation there, it's telling us, is 30. So the row ID is different, the stretched value is different, the count, these are all different. These are things that come from our attribute table. For every elevation, so this is the elevations of 1, and if we scroll down to the elevations of 30, it's basically saying that in the whole continental United States, there are 30,973 cells with elevation of 30 meters. That's what this number comes from. The row ID is this guy, so that's just a coincidence that they're so close together, you know. But this is our elevation. The pixel value is what we're looking for there. So it's 30 meters in elevation, which is, I don't know, pretty high considering how low it actually is. So that's that. And then we skip ahead and we'll start looking at the land cover data set. So I'm going to go and turn this guy off, and we'll turn on the land cover data set and zoom out so we can see the whole thing. All right, so here's our land cover. It's displaying a little funky because we're in the New York. So why don't I just change our display coordinate system back to something that's more appropriate for the US. Doesn't really matter, but this is what we're taking a look at. Okay, so what's the resolution of the land cover data set? Let's collapse all this down and take a look at the one we care about. It's got a lot of stuff in it. So going into the properties, the question is about the resolution. So again, we're looking for the cell size. So here we have another 1 kilometer raster, but the actual resolution would be 1001.042 meters, not squared. I did take a couple points for this if you just reported all of your resolutions in a squared unit, but I gave you a mulligan on the third one just because I wanted to make the point. So I hope you understand. Okay, so that is the resolution. The question 11 is this raster or vector data? Oops. Same thing, raster information, file system raster, zoom in and see individual pixels. So a matrix of cells. The coordinate system. Going back into the properties, we're looking for the spatial reference when it comes to rasters. So the spatial reference, this is our coordinate system right here. It's built on this datum, so WGS84, it's a global data set or global datum, and yeah, it doesn't really tell us what the projection is in this case, but anyway, this is the coordinate system itself. Okay, and what datum was this coordinate system built on? Sorry, that was it right there. The datum, WGS 1984, D stands for datum. Okay, now we're going to the Bailey ecosystems. Question here, zoom to layer. Here are ecosystems, turn off land cover. All right, the data type is going to be polygon, shapefile, feature class. I don't remember what I actually asked there if I gave you multiple choice. It's vector data, basically, shapefile. We get that here. The coordinate system for the Bailey ecoregions, this is it, USA contiguous, Albers equal area conic, USGS version. That's the whole coordinate system. It tells you that there. The projection is Albers. Linear unit is meters, and the datum it's built on is the North American datum of 1983. So geographic coordinate system and datum are, for all intents and purposes, the same thing. This just basically has a defined origin, and we decide if it's decimal degrees or degrees, minutes, seconds. So that's question 15. Then you guys do some work to start extracting attributes and values and sorting and making some calculations. So maybe I'll pause there and then I'll open up again and we'll start talking about the road lengths of Hawaii.